Hello and welcome to the first lesson on mathematical logic. So what is mathematical logic and why are we learning this? Well, mathematical logic is important for mathematical reasoning, and it's also used for electronic circuitry and computer programs. So logic is a system based on propositions. And what are propositions? Well, a proposition is a statement that is either true or false, but not both. So it can't be true and false at the same time. We say that the truth value of a proposition is either true or false, and this corresponds to 1 for true and 0 for false when we're talking about digital circuits. So now we're going to see some examples of what could be propositions. We're going to see some sentences and we'll decide if they are statements and if they are propositions or not. So the first one is, elephants are bigger than mice. So first of all, is this a statement? Because if it's a proposition, it must be a statement. So is this a statement? Yes. Elephants are bigger than mice, that is a statement. So it could be a proposition. So is it a proposition? Another condition for a proposition, it either must be true or false. So elephants are bigger than mice. Yes, that is either true or false. And elephants are bigger than mice, so we can say that this proposition is true. So the truth value of this proposition is true. Let's see another one. 520 is less than 111. So first of all, is this a statement? Yes, it is a statement. So is this a proposition? So basically, can it be true or false? And yes, we know 520 is what's greater than 111. So that means the statement must be false. And if it's false, then yes, it is a proposition because it's a statement and it is either true or false. Let's see another one. Y is greater than 5. So is this a statement? Yes, that is a statement. So it could be a proposition. If it's a proposition, it will have to either be true or false. So is y greater than 5? Well, if we don't know what y is, then we don't know if it's greater than 5 or not. So this one is not a proposition because it doesn't tell us what is y, so we don't know if it's true or false. So that one was not a proposition. Okay, so next one. Today is January 1st and 99 is less than 5. So is this a statement? Yes, that's a statement. So is it a proposition? So basically, can it be true or false? Well, today is not January 1st. It could be when you're watching this video, but probably not. And 99 is never going to be less than 5. So this statement is always false. So yes, this is a proposition. Okay, next one. Please do not fall asleep. Is that a statement? Well, please do not fall asleep. That is not a statement. It's actually a request. If you're asking someone not to fall asleep, that's not a statement. You're asking them to not fall asleep, so it's a request. So if it's not a statement, then it cannot be a proposition, and also it would not be either true or false. It's definitely not a proposition. Only statements can be propositions. Okay, so x is less than y if and only if y is greater than x. So is this a statement? Yes, that's a statement. We're stating a fact. So is it a proposition? Or we have to decide, is it true or false? So if x is less than y, then obviously y is greater than x. So this one is true. So if it's true and it's a statement, then yes, this is a proposition. Because it doesn't matter what x and y are. If y is greater than x, then x is less than y. So this one is true. So just like in algebra we use letters to represent numbers, in logic we use letters to represent propositions. Usually the letters P, Q and R represent propositions. So for example, the proposition P, it always rains on Tuesdays. This proposition will be false because it doesn't always rain on Tuesday, but sometimes. And we have proposition Q, 37 plus 9 equals 46. And that is true. 37 plus 9 does equal 46. In logic, we also have the negation of a proposition. And the negation of a proposition P is like the opposite of that proposition. So the negation of P is not P. And it's written using this symbol. Looks like a rotated L shape or something. So this symbol represents negation. The truth value of the negation of P is the opposite of the truth value of P. And we can use truth tables to represent this. So this is a truth table. On the left column we have P, on the right column we have the negation of P. So if P is true, then the negation of P must be false. And if P is false, then the negation of P must be true, because the truth value of the negation is always opposite. Sometimes we might have a proposition that is neither true or false because it depends on the circumstances. So sometimes it will be true and sometimes it will be false. These are called indeterminate propositions. So if the truth value of a proposition depends on the circumstances, it is called an indeterminate proposition. For example, your father is 177 centimeters tall. That proposition is indeterminate because for some people it will be true, but for most people it will be false. The truth value depends on the circumstances. So it would not have the same truth value for all people. Okay, grade 10, for your homework for next lesson, please create 3 of your own propositions. One proposition should be true, the other one should be false, and the other one should be indeterminate.